What happens when you put a bunch of F1 engineers together to make a rear-wheel drive Japanese sedan? You get this. That's right, a fire-breathing 5-litre V8 making 440 horsepower and 503 Nm of torque going through the rear wheels. Introducing the Lexus ISF. Despite the IS200 and LS400 being JDM icons, Lexus knew they needed a statement that truly evoked real performance to partially cleanse their boring image compared to the Germans. So Lexus went in early 2004 and assembled a small team with a limited budget to work on a higher performance XC20 IS, and 3 years later, the new ISF was unveiled to the public. Fun fact, the chief engineer Yukihiko Yaguchi had previously worked on the iconic Mark IV Toyota Supra. So, whilst you've seen many reviewers, journalists and owners alike drive the ISF to its absolute limit, here at Automotive we appreciate the intensive engineering efforts required to produce a vehicle like this. As with other cars we'll cover in the future, we're taking a deep dive into the engineering choices behind the ISF and how they impact real-world performance, for better or worse, through what we call an automotive X-ray. Each section of this video has been painstakingly divided into the various mechanical parts of the car, such as the engine, gearbox, dynamics, suspension, and of course, the chassis and underbody. With that being said, let's begin. To kickstart this technical review, let's look at the throbbing heart of what powers this monstrous rear-wheel drive V8 sedan from Japan. Dubbed the 2UR GSE, this is a naturally aspirated 5-litre V8 engine that is engineered with Yamaha's F1 engine program. This engine was basically the roided up version of the 1UR FSE found in the LS460 and the 2UR FSE found in the LS600. The 2UR GSE uses a die-cast aluminum cylinder block with steel liners, with its two banks of 4 cylinders arranged at a 90-degree angle, while the forged crankshaft at the bottom of the V rotates around 5 main bearings. But there's a tweak that Lexus did to their usual engine building practices that solidified their reliability to unforeseen heights in the performance world. Instead of securing each main bearing cap with 2 heat-treated steel bolts, Lexus used a 4-bolt technique usually reserved for race engines. These were not your ordinary high tensile fixings. Instead, they were engineered to stretch a precise amount in length as the bolt was tightened to a specific torque. This provides a consistent clamping force to secure each cap to the block, allowing Lexus to effectively resist lateral vibrations generated at the crankshaft by the alternating firing of cylinders on opposite banks of the engine. This tweak minimized potential noise and vibrations at their source, resulting in exceptionally smooth running and incredible durability, which has led to these ISFs not depreciating in value as much as their German counterparts, due to these engines famously lasting for hundreds of thousands of kilometers. Likewise to its derivatives, the ISF has D4S dual and port injection, so carbon buildup is not a problem at all, unlike the 4GR FSE in the IS250 of the same generation. However, for the 2UR FSE, the ports were redesigned and lightweight materials employed for the valve train. This change was to accommodate for the bespoke cast aluminum intake manifold that was redesigned to use the dual intake system, where the primary intake passage supplied sufficient flowability to handle most of the engine's breathing needs. This is why reviewers and enthusiasts alike often complain that the ISF feels like it has almost no drama at the low revs. The intention of the ISF, after all, was for the car to be a Jekyll and Hyde vehicle, where it's smooth at low RPMs and frenetic at the top end. Very similar to Honda VTEC, wouldn't you think? When the engine goes past 3600 RPM, a secondary intake passage will open, lowering the intake pressure loss and increasing the engine's ability to breathe. For this specific engine, the intake ports were machined into a straight edge capsule form to improve intake efficiency, allowing an improved intake airflow coefficient of 11%. with these changes being made which allowed more air to be drawn into the engine to accommodate more power, more valve lift was needed. This was done through switching the valve material to titanium, and this change meant the 2UR GSE had 9% greater valve lift, while lowering the valve spring load by 20% helped to reduce friction across the valve train. Using softer valve springs also means more torque and efficiency at lower revs. This is actually one of the reasons why this engine has such great longevity, as increased friction across the valve train will mean more wear and tear on the valves over an extended period of time. Well, we take all of these changes from the 1UR FSE to the 2UR GSE, we now get an extra 200 RPM and 28 horsepower to play with. To ensure the engine felt responsive, a 30% shorter response time was done through modifying the shape and volume of the intake manifold so that it could be emptied and refilled quicker. The ISF also uses a free-flowing air filter that ensured there were no restrictions at the entry point. So let's analyze the allure of this dual intake system. The 2UR GSE in the ISF was tuned to provide three distinct sounds. Let's play a clip of the ISF in Forza as we launch it from a dig at Server's Paradise. Whilst the game may not give the ISF's oral depth its full justice, the engine gives a basic sound below 3600 RPM when the primary intake passage is the only one used. At 4200 RPM, in that moment when the secondary intake passage is open, you can start to hear the intake roar. And as we build to that 6800 RPM redline, you can now hear a clear induction roar, which coincides towards the top end of the intake range. But there's one fact that might make you puke if you hate fake stuff in modern cars. Those iconic quad exhaust tailpipes that consist of two vertically stacked exhaust tips on each side, they're fake and don't actually directly connect to the actual exhaust pipes. Fun fact, if you remove the bumper, those exhaust tips also go as well. Lastly, the ISF features engine oil and automatic transmission fluid coolers and an oil pump designed for high-speed cornering and hard-track driving. So that's why you often see these get beat on at the Nürburgring and get beat on with little to no issues. We have an engine, but we need something so it operates at its best at any speed. So let's now talk about the transmission. The gearbox in this car is quite special. It's one of the world's first 8-speed automatics in the world, and it's an Aisin AA80E Sport Direct Shift gearbox with sequential shift, which can lock up the torque converter from 2nd through 8th gears. This gearbox is actually derived from the LS460. The SPDS allows for shifts to occur in 0.1 seconds, compared to 0.5 seconds of the V8 F1 race cars at the time. The paddle shifters allow for gear shifting while steering with both hands, and a manual mode can be selected as well. This is also the first conventional transmission that has been able to blip the throttle downshifting and not suffer from unwanted engine braking that can cause the gear shifts to feel jerky in other cars such as the E92 M3. Now, let me show you one of the reasons why we love the sound of the ISF. Notice that vicious rev limiter bounce the car has when put in manual mode. Unlike other cars that auto upshift for you when you hit the red line, even really recent ones, I'm looking at you pre-update Kia Stinger, you have complete control over the shifting. Let's now have a brief look of the ISF's gear ratios. The key takeaways here are that despite a very short first gear, the spread to a deep overdrive at the final gear and a moderate final drive ratio means the ISF can accelerate aggressively in lower gears, but cruise efficiently at high speeds. We can also see that gears 1 to 4 are short for strong low and mid-range acceleration, especially in first and second gear, whilst gears 5 to 8 are progressively taller, allowing for comfortable and efficient highway cruising. So whilst the gears are quite short during hard acceleration, why do people think this gearbox isn't the best? We mustn't forget this ISF still uses a torque converter unlike the ZF trannies in the BMWs, so it shifts smoothly when you're in drive, but not lightning fast. Lexus have gone and stuck with their choice of a torque converter over a DCT and even the new IS500, as you get less wear and tear compared to a DCT, which needs 2 clutches, and you will always get more wear on a smaller clutch for even gears. When you combine the powerful engine and sharp transmission, you get a pretty fast car. In 2008, Car and Driver tested the ISF and got a 0 to 60 time of 4.2 seconds, and it has an electronically limited top speed of 270 km an hour or 170 miles per hour. That's pretty quick. Let's now move on to another aspect of what makes this car so special: the dynamics. Let's start off with the steering. The ISF uses electric rack and pinion steering with a 13.6 to 1 gear ratio, meaning it's pretty direct. The drivetrain is also linked to Toyota's Vehicle Dynamics Integrated Management, which among other things adjusts the weight of the steering based on vehicle speed. This is very important, as with a traditional hydraulic or non-power assisted setup, the direct connection between the rack and the pinion allows for the loaded up tires to vary the weight of the steering. VDIM does this, but electronically, to mimic and give the driver that feedback when pushing the car. But Lexus, and it seems the customers, weren't quite satisfied with the steering feedback at the limit. So for the 2011 and 2013 model years, the electric power steering system was modified to provide a sharper feel. The ISS multi-link rear end, which we'll get into more detail in the next section, whilst quite responsive from factory, isn't aggressive enough when it comes to rear camber, with it only being at negative 0.75 degrees. In 2011, this was changed to negative 1.5 degrees to improve rear end grip, as well as allowing for sharper and more neutral handling at the limit. The Lexus ISF comes equipped with Brembo cross-drilled brake rotors that are 40.2 inches at the front and 13.6 inches in the rear, and 6-piston front and 2-piston rear aluminum calipers stamped with the Lexus emblem, along with 19-inch BBS forged aluminium alloy wheels. The OEM Brembo front calipers, in addition to Lexus, are actually used by Mercedes-Benz and other performance manufacturers. Whilst the stock brakes are great, the drill rotors, when and if used aggressively, can form mini cracks around the holes. Another important thing to note is that front and rear tyres be different sizes, with 225/40 R19 at the front and 255/35 R19 at the rear. This is a staggered wheel tyre setup, and in powerful rear-wheel drive setups, these setups are almost always used, as wider rear tyres help put the power down more effectively. Before 2010, the ISF used a brake-based torque vectoring pseudo LSD that basically simulates the behavior of an LSD through the VDIM system. But there's an issue with this type of setup. There's usually delay where the LSD is only activated when the inside wheel starts to slip, not before. So in 2010, the ISF added the biggest change to its handling, making such a difference that it shaved 2 seconds off its lap time around Japan's Fuji Speedway. It's a torsion limited slip differential that actually redistributes torque lost when a wheel loses traction during cornering, without limiting engine output. Along with the torsion LSD, Lexus has also introduced new differential oil that suppresses the potential pitfall of an LSD, making the car feel jerky, noisy, and unpredictable. Let's now move on to the quads and hammies of the ISF, the suspension. Like all XC20 IS cars, the ISF uses a double wishbone front suspension and multi-link rear architecture, with the upper wishbone being made of stamped steel whilst the lower wishbone is made of regular steel. The multi-link rear uses 5 distinct links and a coil-over shock. The choice of using a double wishbone front not only avoids understeer at the limit compared to struts through camber gain where you load up those front tyres, but you also get a superior ride quality that soaks up bumps. After all, this is a small luxury sedan. The ISF also uses monotube type front and rear shock absorbers, with the front absorber using a rebound spring and a multi-leaf type linear control valve. One of the reasons why a monotube design was preferred over a twin tube design was as a lot of the suspension testing for the ISF was actually conducted at Fuji Speedway, which contains the iconic 300R high-speed right-hand sweeper. Monotubes offer better damping against high-speed impacts, however at the cost of a stiffer ride than twin tube setups, as the gas pressure in the shock absorbers is usually higher. So in theory the ride should be amazing, right? Well, not so much. Owners for the pre-2011 models have said that the suspension is way too harsh even on the road. Let's examine why. The 2011 model brings 5% softer front spring rates and stiffer rear spring rates, but 10 to 20% stiffer damping within the Takiko shock dampers, depending on the shock piston speed. but the tweaks that sealed the deal? Different toe arms in the rear for revised suspension geometry, as well as thicker sway bars were used, which allowed for a car that didn't just ride better, but handle better as well on the limit. But Lexus weren't done there yet. In 2012, they changed the shocks from Takiko to Sux and modified the damping force characteristics in the rebound stroke of the front and rear shock absorbers in the extremely low piston speed range to allow for better ride comfort and less aggressive damping at lower speeds. They've also optimized the shape of the rear spring bumper to ensure the rear end doesn't feel too crashy, with the rear rebound springs also being removed. These small but significant changes to the ride quality, as we can see with the graphs showing a notable decrease in damping force compared to the previous models. And finally, in 2013, they revised the suspension again to soften the front coil spring rates by 2.5% and stiffen the rear coil spring rates by 13% compared to 2012. To ensure vehicle stability, the rear suspension control arms and the toe control link sub-assembly were changed. The front and rear stock shocks were also tweaked to stop the ride from feeling too bouncy when the suspension settles back into its normal position, known as a rebound stroke. When you combine all these changes, especially with that post 2010 Torsen LSD, it's easy to see why the post 2011 models are often the most desired ISF models on the used market, with some of the later years even getting close to the price of a used RCF. Wow! But the story doesn't end there in terms of the suspension. Due to stiffer spring rates compared to the IS350, Lexus initially ensured that the lower control arm bushings were a little bit softer to counteract this. This is why you see most ISFs having wheel spin when accelerating hard from a dig. However, in 2011, Lexus retuned the rubber bushings within the end link of the suspension to make them stiffer laterally for hard acceleration by keeping the intention of low NVH while making them softer torsionally. With all that suspension mumbo jumbo out of the way, let's now delve deeper into the final pieces of the puzzle, the chassis and underbody. One of the key changes made to the ISF compared to the standard IS was that the vehicle body was lowered by 1 cm. The aluminum hood features a bulged appearance, with a sharper curve than the standard IS to accommodate for the added space needed to contain the 2UR GSE. Its drag coefficient is 0.30, giving it very good high-speed stability on tracks such as the Nürburgring with a lap time of 8 minutes and 18 seconds. The exterior also features a wire mesh grille, changed side fenders and skirts along with side air vents. The reason why the ISF is actually quite light compared to its predecessors is because the ISF is based on the IS350 and doesn't use any body strengthening whatsoever, despite the car's added weight, power and additional lateral Gs. Officials at Lexus have actually said this doesn't come as a surprise at all, and as the second generation ISF is actually based on the GS platform, which itself was designed to handle a V8. The ISF still uses a lot of steps still that the other IS cars of the same generation use on the underbody as well, so it's easy to infer that with the limited budget and time afforded to a small team of engineers, almost all the money went towards the engine and transmission. So, real world performance time. Even with all this engineering, why do reviewers often put the ISF just a notch below the iconic E92 M3? This is for a few reasons. The E92 M3 has a redline of over 8,000 RPM, whilst weighing over 100 kilos lighter. And as the ISF is actually quite front heavy with a front rear balance of approximately 54-46, this actually makes the ISF around the Top Gear test track over 1.5 seconds slower than the E92 M3. Let's now head into the concluding remarks. Overall, what are my thoughts on the ISF? It's honestly one of my favorite sedans ever. When you combine its reliability and really low asking price compared to the RCF, GSF and especially the IS500 and LC500, it's a great car. In my personal opinion, as it weighs the lightest out of all the V8 F cars, it's the most raw, best handling and most fun out of all of them. If you've got any other cars you want us to conduct an automotive x-ray on, let us know in the comments. Thank you so much for the support already with the previous videos. Let's keep this up so we can continue to make this a regular thing on YouTube, where we really break down and dissect some of the best cars ever. Much love to you all, and I'll see you in a bit.